Cookies are fundamental to how modern websites work. They are small pieces of data that websites store on your computer to remember information about you and your interactions with the site. Cookies serve several important purposes. They remember your login details so you don't have to sign in every time, store your preferences like language settings or themes, and keep track of items in your shopping cart as you browse an online store. To understand how cookies work, we need to learn about HTTP headers. HTTP headers are pieces of information sent between web browsers and servers. They contain metadata about the request or response, including cookie data. There are two specific headers that handle cookies. The set cookie header is sent by the server to the browser to create or update a cookie. The cookie header is sent by the browser back to the server, containing the stored cookie data. This is where cookie parsers come in. A cookie parser is a tool or piece of code that extracts and interprets cookie data from these HTTP headers. It takes the raw header strings and converts them into a format that applications can easily work with, handling the parsing of cookie names, values, and attributes. The set cookie header is how servers instruct browsers to store cookies. When a server wants to create a cookie on the client side, it sends this special HTTP header in its response. The basic syntax of a set cookie header consists of a cookie name, an equals sign, the cookie value, and optional attributes separated by semicolons. Let's break down each component. The cookie name identifies the cookie, and the value is the data you want to store. Both are required components. Now let's explore the optional attributes that control cookie behavior. The expires attribute sets an absolute expiration date for the cookie. The max age attribute is an alternative to expires. It specifies the cookie's lifetime in seconds from when it's received. The domain attribute specifies which domains can access the cookie. If not specified, it defaults to the current domain only. The path attribute determines which URL paths can access the cookie. It defaults to the current path if not specified. The secure attribute ensures the cookie is only sent over HTTPS connections, providing protection against network eavesdropping. The HTTP-only attribute prevents JavaScript from accessing the cookie, providing protection against cross-site scripting attacks. Here's a complete example combining multiple attributes. This creates a secure session cookie that expires in 1 day and is only accessible via HTTPS. This cookie named Session ID with value ABC123XYZ will expire in 8/6400 seconds, which is 24 hours. It's accessible across all subdomains of mysite.com and all paths, but only over secure HTTPS connections and cannot be accessed by JavaScript. Understanding set cookie headers and their attributes is crucial for proper cookie management. These attributes give you fine-grained control over cookie behavior, security, and accessibility in web applications. The cookie header works in the opposite direction from set cookie. While set cookie is sent from server to client, the cookie header is sent from the client browser back to the server. The cookie header contains all the cookies that the browser has stored for the current domain and path. It's structured as a semicolon-separated list of name-value pairs without the additional attributes that were in the set cookie header. Let's break down this cookie header structure. It starts with the header name, cookie, followed by a colon and space. Then we have the cookie data as name-value pairs, separated by semicolons and spaces. The browser automatically manages which cookies to include in the cookie header. It only sends cookies that match the current domain and path of the request. This is a crucial security feature that prevents cookies from being sent to unintended servers. Here's a practical example showing the relationship between set cookie headers that create cookies and the cookie header that sends them back. Notice how the cookie header only contains the name-value pairs without the additional attributes like path, domain, or expires. The key difference is that the cookie header strips away all the metadata attributes. The browser uses those attributes internally to decide which cookies to send and when, but the server only receives the essential name-value pairs it needs to identify the client and maintain state. Now we'll explore practical examples of using cookie parsers in JavaScript. We'll cover installation, browser usage, and server-side implementation with real code examples. First, we need to install a cookie parsing library. The most popular options are the cookie package or JS Cookie. You can install either using NPM or Yarn package managers. In the browser environment, we can use JS Cookie to easily parse and access cookies. First, we import the library, then we can get all cookies or access specific ones by name. In a Node.js server environment, we use the cookie package to parse the cookie header from incoming requests. We access the cookie header from the request object and parse it into a JavaScript object. The cookie parser transforms a raw cookie string into a structured JavaScript object. This makes it easy to access individual cookie values by their names, rather than manually parsing the string. Once cookies are parsed, you can easily access individual values, check if cookies exist, and provide default values. This makes cookie handling much more reliable and maintainable in your applications. Cookie security is critical for protecting user data and preventing attacks. Two essential security attributes every developer should understand are secure and HTTP only. These attributes provide fundamental protection against common web vulnerabilities. First, let's examine the secure attribute. When this attribute is set, the cookie will only be transmitted over encrypted HTTPS connections, never over plain HTTP. This prevents attackers from intercepting sensitive cookie data through network eavesdropping. Here's the critical difference. Cookies without the secure attribute can be transmitted over both HTTP and HTTPS connections. This creates a vulnerability where attackers on the same network can intercept the cookie data. With the secure attribute, transmission only occurs over encrypted HTTPS connections. Now let's explore the HTTP-only attribute. This attribute prevents client-side JavaScript from accessing the cookie through the document.cookie API. This is crucial for preventing cross-site scripting or XSS attacks, where malicious scripts try to steal session cookies. Without HTTP-only, malicious JavaScript can access cookies using document.cookie. This allows XSS attacks to steal session tokens. With HTTP-only enabled, JavaScript acts as blocked, but the cookie still works normally for HTTP requests between browser and server. For maximum security, combine both attributes. A cookie with both secure and HTTP only provides protection against network interception and XSS attacks. This is considered the security baseline for any cookie containing sensitive information like session identifiers. Beyond these core attributes, follow additional security best practices. Use short cookie lifetimes with appropriate max age or expires values. Never store sensitive information like passwords or credit card numbers directly in cookies. Consider using the same site attribute to prevent cross-site request forgery attacks. Remember, cookie security is not optional in modern web development. Always use secure and HTTP-only attributes for sensitive cookies, implement proper lifetime management, and follow security best practices to protect your users' data and maintain application security. Server-side frameworks provide powerful abstractions for working with cookies, eliminating the need to manually manipulate HTTP headers. These frameworks offer convenient APIs that handle the complexity of cookie parsing and setting behind the scenes. Let's start with Express.js, a popular Node.js framework. Express provides simple methods to set and retrieve cookies without dealing with raw headers. Here's how you can set a cookie using Express. Retrieving cookies in Express is equally simple. You can access cookies directly from the request object, especially when using cookie parser middleware that automatically parses incoming cookie headers. Django, Python's popular web framework, provides an even more object-oriented approach to cookie handling. Django's request and response objects have built-in methods for cookie operations. Ruby on Rails takes cookie handling even further with its elegant syntax. Rails provides intuitive methods that make cookie operations feel natural and readable. The key advantage of these frameworks is middleware support. Middleware components automatically parse incoming cookie headers and make them available as convenient objects, eliminating manual header parsing entirely. Compare this framework approach to manual header manipulation. Instead of parsing cookie strings and constructing set cookie headers manually, frameworks provide clean APIs that handle all the complexity, making your code more readable and less error-prone. Server-side frameworks transform cookie handling from a tedious, error-prone process into simple, intuitive API calls. They provide automatic parsing, convenient setting methods, and built-in security features, allowing developers to focus on application logic rather than HTTP header details. While cookies have been the traditional method for client-side data storage, modern web development offers several powerful alternatives that can be more suitable for different use cases. Local storage provides persistent client-side storage that survives browser sessions. Unlike cookies, data stored in local storage remains available until explicitly cleared by the user or application code. Session storage is similar to local storage, but with a key difference. It only persists for the duration of the browser tab session. When the tab is closed, all session storage data is automatically cleared. Let's compare these three storage mechanisms side by side. Notice the significant differences in storage capacity, persistence behavior, and HTTP transmission. One major advantage of local storage and session storage is performance. Unlike cookies, which are automatically sent with every HTTP request to the same domain, these storage mechanisms only send data when explicitly requested by JavaScript code. JSON Web Tokens, or JWTs, represent another modern approach to authentication and authorization. JWTs are self-contained tokens that carry user information and can be stored in either cookies or local storage, each with their own security considerations. Understanding cookies, cookie parsers, and HTTP headers remains fundamental for modern web development. While newer storage mechanisms offer advantages in specific scenarios, cookies continue to play a crucial role in web authentication, session management, and cross-domain communication. The key is choosing the right storage mechanism for your specific use case and security requirements.